Spark UI is one of the most practical tools every data engineer should learn. It is not just a monitoring screen. It is a diagnostic guide that helps you understand what happened inside a Spark job and where the real bottleneck is hiding. In Databricks, Spark UI is especially useful for investigating both performance and cost issues. A strong way to use it is to follow a simple flow. First, use the job's timeline to identify major issues. Then look at the longest stage. Next, check for skew or spill. After that, decide whether the stage is input and output bound. Finally, look for other causes of slow stage runtime. This video will show you how to read jobs, stages, long tasks, shuffle, spill, skew, and failed stages in a practical way. A good Spark UI investigation usually starts at the jobs page. A job is created when you trigger an action, such as count, write, collect, or save. Each job can contain one or more stages, and each stage contains many tasks. When you open the jobs page, start by looking at duration. Long job duration is the first clue that something may be wrong. Then check how many stages were involved, how many tasks ran across those stages, and whether the job succeeded or failed. You should also watch for red flags, such as repeated retries, many tiny jobs, or a long-running job that clearly stands out from the rest. The simple rule is this: start from jobs, then drill into the slowest stage. After finding an interesting job, the next step is to read the stages page. Stages are groups of tasks that run in parallel and produce part of the job result. In practice, the longest stage often points directly to the bottleneck. On the stages page, first check duration. Which stage took the longest? Then look at how many tasks completed, how much input and output data moved, and especially the shuffle read and shuffle write values. If one stage takes much longer than the others, or if shuffle read and write are very high, that stage deserves deeper analysis. Also remember that a shuffle, such as a join, reduced by key or group by, often creates a new stage. If you find the slowest stage, you usually find the bottleneck. Sometimes a stage looks slow because only a few tasks are taking much longer than the rest. That is why the tasks view is so valuable. A stage finishes only when its slowest tasks finish, so even a small number of outlier tasks can delay the whole stage. To investigate, sort tasks by duration. Then compare the slowest tasks with normal ones. Look at task duration, executor time, input size, and garbage collection time. Ask yourself whether those slow tasks are reading more data, waiting longer, or processing larger partitions. Long tasks often point to uneven data distribution, excessive shuffle or spill, poor partition sizes, or slow input reads from storage. Outlier tasks delay the whole stage, so they are never just small details. Shuffle is one of the most important signals in Spark UI because it shows how much data is moving between stages. Shuffle read means data is being fetched from other executors for the current stage. Shuffle write means data is being prepared and written for the next stage. You often see shuffle during joins, group by operations, aggregations, distinct, or repartitioning. Why does this matter? Because large shuffles usually mean expensive data movement. They increase network traffic, disk input and output, and stage runtime. When you inspect shuffle metrics, look at total shuffle bytes, fetch wait time, and whether the transformation is wide. The key idea is simple. Large shuffles often mean expensive data movement, and expensive data movement often means slower jobs. Spill happens when Spark runs out of memory and starts writing data to local disk. This is an important signal because disk is much slower than memory. The more Spark spills, the more disk input and output it creates, and the slower the job becomes. In Spark UI, you should monitor two related metrics: memory bytes spilled and disk bytes spilled. Higher values usually mean more pressure during execution. Spill often follows heavy shuffle, large joins, big aggregations, poor partition sizing, or insufficient executor memory. When you see spill, do not treat it as just another number. Treat it as a warning sign that the workload is pushing beyond what memory can handle efficiently. Skewed partitions are a very common reason why stages look stuck near completion. In a healthy stage, most tasks finish in a fairly balanced way. But with skew, most tasks finish quickly while one or a few tasks keep running much longer. This usually happens because the data is not distributed evenly. One hotkey, one oversized group, or one uneven join can send much more data to a small number of tasks. In Spark UI, skew often appears as one task that is much slower than the others. progress that seems stuck near 99%, or executors that look badly imbalanced. Common fixes include salting hot keys, repartitioning with a better key, or broadcasting small tables to avoid large shuffles. Balanced partitions create balanced work. When a stage fails, do not just rerun the job and hope for the best. A failed stage is a signal, and the error message is part of the diagnosis. Start by reading the reason for failure carefully. Then inspect task attempts, failed tasks, executor logs, standard output and error logs, and cluster or infrastructure metrics. Common causes include out-of-memory errors, fetch failures during shuffle, executors being lost or removed, disk full conditions, network issues, or spot instance loss. You should also look for patterns. Are failures repeating in the same stage? Are they linked to shuffle or aggregation? Are executors disappearing under resource pressure? The best mindset is to find the root cause first, then fix the environment or the code, and only then rerun with confidence. Let us finish with the most important takeaway. Spark UI works best when you use it as a diagnostic workflow. Start with the right mindset. Observe first, measure the bottleneck, then validate after tuning. A practical sequence is: begin at jobs, drill into stages, inspect tasks, review metrics, apply a fix, and then validate the result. For long jobs, check duration, retries, and queuing delays. For shuffle, look at read and write volume and large data movement. For spill, inspect memory and disk spill. For skew, look for uneven task duration and imbalanced work. For failed stages, inspect errors, executor loss, and task failures. Spark UI is not just monitoring. It is your diagnostic map for understanding, fixing, and validating Spark performance issues.